Good morning, everyone. This is Carl Griffith from Graybar. Welcome to our G2 Talk webinar today. I'm the Director of Emerging Technologies, and today our subject will be how to win with wireless lighting controls, a technology that I'm passionate about, and so is our presenter today, so we're glad that you're here. I'd like to tell you a few things about our G2 Talk webinar series if you haven't been on them before. One thing is if you're one of the first 50 people to get online with us today and stay for the presentation, we'll send you an email, and that email is worth $5 for a cup of coffee at a very large international coffee chain. So check your email today, and if you get the certificate in the email, you can cash it in for some coffee. The presentation today will be archived. It'll be archived on graybar.com. If you go to graybar.com and just look for the G2 Talk webinar logo, there's a little archive button there, and you click on it, and this presentation will be up there archived, so you can review it again or share it with colleagues or friends. And you can also, if there's any accompanying documentation there, maybe the presentation in a PDF format or a white paper, that will also be there in the archive. There's a Q&A that goes along with this presentation today, so you'll notice at the bottom of the screen you'll see a little QA area there. If you click on that, a dialog box will open up, and you'll be able to type a question in there. We'll respond to those questions at the end of our presenter's presentation, and any questions that we don't get to, we'll respond to them via email later today or tomorrow. Before we get started, I just wanted to give you a little bit of information about Graybar. We look at the world this way. We look at the world in a way where Graybar helps our customers power, network, and secure their facilities with speed, intelligence, and efficiency. Our conversation today about lighting controls fits right in there, because there will be conversations about networks and power, and there will also be conversations about intelligence and efficiency in our buildings. So as we move forward, I'd like to introduce to you our presenter today, who is Scott Ziegenfuss from Lutron. Scott's a subject matter expert when it comes to buildings, and he understands buildings holistically from a sustainability, energy, IT, codes, and automation perspective. And he has a very unique understanding of buildings and how that building ecosystem works. And today we're going to understand how controls and wireless lighting controls fit into that ecosystem. Scott's a double E and a graduate of Lafayette College. He's also a lead AP. For you all on the line that understand all the lighting credentials, you can see some of that behind Scott's name on the slide that you see right now. We're just so fortunate to have Scott and his information that he'll give us today about wireless controls. So without any further delays, I'd like to pass the baton over to Scott. Thank you very much for being with us today, and we look forward to your presentation, Scott.
Thank you, Carl. I appreciate it, and welcome from Lutron's world headquarters here in Pennsylvania. We're going to talk a little bit about wireless lighting controls today. I want to talk couple of things. We're going to talk why lighting controls, period. We'll talk a little bit about wireless, too, and then we'll go into the technology of wireless, too. And then we're going to end with a case study, a little bit of talk about what they like to call the world's most famous office building, which, of course, is the Empire State Building, and how wireless lighting controls fit into their sustainability schema. So first of all, though, why lighting controls? And, you know, Lutron's been in lighting controls since literally the late 50s, early 60s. But lighting controls themselves really were more a thing people got because they thought they should, for the look, for the feel, for the area. But things have changed, especially the energy. Energy became such a big deal in the 2000s. I always say thank you, Enron. And what happened was energy codes became very prominent. And energy codes looked at the buildings, and you'll see later that lighting actually is a big part of buildings' electrical energy. So energy codes came along and they became, and I talk about the big three when I talk about energy codes. I talk about ASHRAE 90.1, I talk about IECC, and for those in California, I talk about Title 24, Part 6, of course, is the big three energy codes. By the way, this is a great slide. If you ever get the chance, because energy codes are moving the market so much, they're not saying you should, but more saying you have to actually adopt some of these strategies. So if you want to know what's going on in your state, definitely go to the bottom there where it says www.energycodes.gov, and you'll see on the left-hand side it says adoption. Then you can go to your individual state and see what energy code and what revision of energy code your state is following. So you can make sure that you're in compliance and what's going to happen next and when they're getting the new revision coming in. As we go through, I'm going to talk a little bit, I'm going to kind of focus on ASHRAE 90.1 very quickly and how it's moving forward. I kind of think of it as the middle. All the energy codes are fairly close, and as far as what they ask for and when they're asking, I think probably a little tougher in the energy codes is going to be apparently Title 24, Part 6 here in California. They do things like asking for demand response now, their new code that just came out this last July, or ASHRAE 90.1. Their code, the newest one that people are adopting is 2010, but 2013 is actually already published. And IECC, I always say, is just a little bit probably lenient, only because I think of things like today on their 2012 code, they ask for manual daylighting. But again, they do the same thing. The big thing you see here is how things changed. And they changed from the ASHRAE 2007 to 2010. Everything was about light power density. Bring the light power density of the room, the energy of the room down just through the type of lighting fixture. And really, if you did just a control of a time clock, you were good. In new construction especially, they changed. In 2010, it became about multi-level controls, occupancy and vacancy sensors, not only for partial on or manual off, but also for partial off. We'll talk about that. Daylighting controls came into effect. All of these things that used to be a thing that you did because you wanted to save energy and save money, now you're doing because you have to. So you want to make sure you understand that. What code is your area following? That's a big deal. So as the code's involved, when we're looking at the new code, let's say ASHRAE 90.1 2010, especially in a new construction, what used to be okay to just have a switch and have lights that just turn on and off, now it's changed. So we have the capability of having at least bi-level switching. And in fact, in Title 24, many times in California, you have to go beyond that and have fully continuous dimming where things are moving towards. Or basically, at least that capability. Making sure you have aux sensors and daylight sensors in that same room now. That capability. And of course, wireless comes into that because it's easy to add before, after the fact. And that's the great thing about wireless control. Now, the retrofit opportunity is a little different. Like I started to say is, most of the codes don't have quite the requirements for retrofit that they do for new construction. Now, I wouldn't say that. I will say that Title 24 is fairly stringent on retrofit. Maybe the only thing they're not asking for usually is the demand response capability, but daylighting and things like that they are. ASHRAE is asking for basically at least time clock and retrofit unless you totally change the space, but they are moving forward to more of a let's look at aux sensing, let's look at different schemas to be able to control the lights, not just to bring the lights down with light power density, but to let's turn them off when they're not being used, and we'll talk about it, or at least turn them down when they're not being used. And there's a great opportunity there because, again, that's becoming a big deal. Remember, there's a lot of large cities now. I know Philadelphia just happened that benchmarking your energy using Energy Management Portfolio is actually starting to happen. So that, again, is a push again to start coming in not just for new construction, but also for retrofit and coming in and making them more energy efficient. And why lighting? Because, 2/3 of the electrical energy in your building is basically taken up by pretty much lighting and HVAC. And we're half of that. We're pretty much equal to HVAC in the amount of electrical energy we use in a building. And we're actually, though, a little, I'm going to say, easier to control because many buildings don't have a lot of control. You can come in and you can add aux sensors, especially wireless. You can add daylight sensors. You can change out the lighting fixtures to an LED type fixture for less light power density. There's a lot of things you can do to affect energy right away, and that's a big deal. And that's, like I said, that's the reason because why lighting is so important, because we are 1/3 of the electrical energy you're using in a normal commercial building. And that's why many people have said to be able to do that, but also the good thing about lighting is you can affect the lighting without affecting the productivity. Just to save energy, if it hurts productivity, because people need light, that's the problem. Well, the good thing is you can usually reduce light 10, 20% without the human eye ever knowing it. The great thing is if you did it over like a 30-second period, if I reduce light within like 30 seconds by 20%, there's been many studies by Lawrence Berkeley and others that have said that my pupil, which will automatically adjust, my brain will never see it. That's the good thing about lighting control. So you can actually bring the energy cost down and not affect productivity. In fact, you can increase productivity because if you're like me, I'm an old engineer. When I'm working on a computer, a monitor, I need lower light. When I'm working on paper, I need a lot more light than the young engineers that are around me. So again, I can increase productivity with still saving energy, and that's the big deal. So why wireless? Well, I think it's kind of obvious to a lot of people. Why wireless? Wireless is because I can get in and not have to disrupt. Many of you might have maintenance contracts that come in and improve things that are already there, that retrofit market. It allows me to come in and it allows me to make changes quickly, to do additions in a quick amount of time. Time is money. So I don't have to, if I need an aux sensor, and we'll talk about that, I don't have to go up and get into the ceiling, get an 1800 box put in there, put in power packs, fish wire. I don't have to do that. I can just put the sensor in. And because I can do that, I can do more in the same period of time. So again, time is money. And that's a big deal. So again, those performance contracts, that retrofit capability is great. But also on new construction, because if you've ever worked with sensors, again, that are being told to you to put in from energy codes, if you've ever worked with sensors that you put in maybe an aux sensor but didn't cover the whole area, you weren't quite sure, what happens when you need to put a second one or move that sensor? That's a big deal. But if you had wireless, it's not a big deal. It's simply pop it out of one area and put it into another because it's not the same hardwired capability. So when changes for churn and things like that happen, that's a major cost savings and a major liability, major effort to actually minimize your liability. And this is a great little slide. We did some studies on this, and we studied that, in a typical aux sensor, if I want to go in and I want to put in wired aux sensors for labor and materials, again, you start putting in the 1800 boxes, you start putting in the power packs, you start putting in the wires and all that, and you can usually get, as we put an average of 9 sensors a day. You used wireless and set the whole thing up, you're now up to 32 sensors a day. That is a great, amount of time savings for you to be able to come in and bid the job and be able to get in and out of that job, or to be able to do the job if you have to do it after hours, so not to disturb people. That's huge for you, and that's the real reason for wireless. Again, that major amount of downtime. I know, especially, like I said, on maintenance contracts, you have to be able to go in and maybe do it after hours. You need to be able to do it, because again, understand something. Energy is usually averaged anywhere from $2 to $4 per square foot in an office building. People are $200 to $300 per square foot in an office building. So the trick is you want to keep productivity going as long as you can without impacting that in any way, because even if you impact productivity by 1%, you just blew the whole energy budget. That's why they want to make sure things keep going. That's why you might want to do things after hours. You might want to be able to come in and if furniture changes, if fake walls come up and make one office into two, or take two offices and make them into one all the time, to be able to change that configuration. But it's not just even about the sensors. It's also about the controls in the wall. If they're wireless, to not have to cut out that J box, to not have to run the wires in the wall, or if somebody looks at you and says, "Could I have a control in this room?" and you look around and the room is all glass, and you go, "What do I do?" Well, if you can put a wireless control right on that glass, that makes life, again, minimizes your risk. Gets you in and out and allows you to make that customer happy. Those are the reasons why you do this. Again, the wireless advantage is to mitigate risk. What about not being able to get into those ceilings that have asbestos? Again, being able to work on that glass and actually put a control right on there, or not have to cut into that beautiful woodwork because you're working into an historic building. Doing things like that, mitigating risk is huge for you. Or that performance contract that says you have to get in and get out within a certain period of time. But you want to be able to add stuff. These are the things that wireless gives you. And that is a huge advantage on what we want to do. Let's talk a little bit about wireless itself and some of the wireless technologies out there. We'll talk a little bit about what Lutron uses and why we do it that way, but also we'll just explain some of the other things. Now, why did they ask Lutron to talk about wireless? Probably for this reason. And I was actually part of the development team here when I actually used to do engineering. Lutron actually developed the first radio frequency lighting control system in the world, called Radio Raw back in 1997. Well, we developed it for 1997. 1997 is when we actually released product. So Lutron has had, it's coming on almost 20 years, getting close to that, of worth of radio frequency lighting control system capability. And the one thing you have to remember when it comes to lighting control compared to other types of control, like my friends in the HVAC world, is lighting control, it better work. Because it's so visual for people. When somebody walks into a room and pushes a button, they expect to see a light to turn it on. If it doesn't happen right away, people actually get frustrated. It's not like turning on a web page. It's not like you go to Google and you turn it on. If it takes 30 seconds for the web page to come up, you're like, okay, I can wait for this. You may get a little annoyed, but it's not that big of a deal. If it takes 20 seconds, whatever. 20 seconds to turn on lights when I push a button and it's still dark is not a good idea. Or when an aux sensor sees me is not a good idea. People get very disheartened at that. So again, lighting control has to work every time I push, and it has to work all the time. So that's one thing to always remember when it comes to this. That's why it's good to be able to choose the right type of technology. Now, there's a couple of different ways you can go. You've obviously heard of the 900 megahertz, 2.4 gigahertz band. If you do anything called Wi-Fi, IEEE 802.11 standard, that's what they're talking about. That runs under actually FCC. I'm going to give you a little background. FCC 15230.235, which is, of course, basically general consumer electronics that you can buy. You don't need a license for. But they're what they're called constant transmitters. And a constant transmitter means exactly that they can transmit 24/7, all the time, all day. That's why 2.4 gigahertz, which there are lighting controls within that, absolutely, but they're also going to compete for that bandwidth with things like baby monitors, again, the Wi-Fi, your blue little Wi-Fi router that you bought at Best Buy or Walmart. They're going to compete with all those different wireless devices that work within this band, this 900 or 2.4 gigahertz, what they call an ISM band. That's what those are for. Lutron decided to a little different way, and this is another way to go. There is also something called a periodic radiator band. If you want to look it up, it's under FCC 15.231. The periodic radiator band says to live here, you can't transmit constantly. So basically the transmission after somebody does something, let's say a button push, an action, whatever, is that when you do it within around 5 seconds, 5.6 to be exact, you need to be able to do all the transmission and you are done till the next time somebody else does an action. So all transmission has to happen, which means we're not transmitting constantly, which means anybody else within that band is not transmitting constantly. Now, I know in the 2.4 gigahertz band, they have multiple things to help you eliminate some of that congestion. You'll hear things like frequency hopping spread spectrum or direct sequence spread spectrum or things like that. It's still a limited band. So that's why we like living in a band that people are not transmitting constantly. We find that less people on in traffic, as I like to show this one, less people on the highway, it's easier for us to change lanes. It's easier for us to drive at a constant speed. Same idea. Because, again, things have to work all the time. So, again, whichever way you want to go, that's just something to think about. Just remember that lighting does need to work. Let's talk a little bit about projects. And the project that we're going to talk a little bit about is very simply, as I said, the world's most famous office building, which is the Empire State Building. The Empire State Building, actually, a lot of it was basically retrofit. They were looking to be basically economically viable and environmentally sustainable, but they also wanted to be like a model for buildings like this to move forward. They were going to use their prestige. They had a couple of things. They didn't want to compromise, again, productivity or the tenant capability inside of there. They wanted to reduce cost. They wanted to reduce time. They wanted viable economics, things like that. That's what they wanted to make sure happened, and that was a big deal for them. So they started out, they said, let's look at some wired capability. We're going to put in aux sensors, and we're going to look at the light power density, which is about what ASHRAE 90.1 is talking about 1 watt per square foot. That's what they were going to look at. And they said, that's great, that's good. But they wanted to get a little more advanced, and they decided on the next specification, let's see if we can get our light power density using LED light sources down to 7 watts per square foot. Now remember, that's energy coming in, not light coming out. So we wanted to make sure they had enough light capability for everything that they needed to do, but they wanted to get down to 7 watts per square foot. They also thought about not only using now occupancy sensors to even help that beyond, they also wanted to add daylighting there. And they were still thinking about wired with all that capability. The next phase that they were looking for was they decided to go with, well, wait a second, let's look at wireless. Can that make life easier for us? Can that also increase our ROI? Can that get us, get people in and out and get us up and running faster? All those things that are important to those property managers. Absolutely. Well, you looked at the installed costs, you looked at the fixtures and controls for aux sensors and 1 watt per square foot, and the labor to put that in. Again, everything's going in, everything's going to be wired, especially on that control side. Like I said, you want to put a wall control in. You're putting that J box. You want to put a aux sensor in. You're getting that power pack. You're putting that 1900 box. There's more things you need to do. And then they decided, well, let's get down to 7 watts per square foot. Well, the fixtures are a little more expensive, but we'll make it up on the ROI. Not a problem. The life expectancy, initial costs, first costs are more expensive. We're going to add the daylight sensors, which will also bring our first cost more expensive. We'll make it up on ROI. That's good. Labor is going to increase a little bit here, but that's all in the wired spectrum. This is where they looked at. If we go wireless, we talk about, gee, there's a little bit less cost in the first cost. Well, there's a little bit less cost because, again, you don't need that 1900 box anymore. You don't need that power pack for that aux sensor. So there's some things or that daylight sensor. So some things you can eliminate as far as that goes. So that's what happened with the wireless. First cost in equipment came down a little bit, you can see. Labor came down significantly. Because, again, you were able to come in, put it in, get out, and, again, mitigated your risk, because if you put it in the wrong spot, you can easily move it, too. That made life easier also. You didn't have to make sure, I didn't know we were going to put this too close to a vent, and now the vent's now making actually the air handling unit was now actually working, actually affecting the aux sensor that went in there. Now you have to move it. Well, what do you do? And this is where that happened. And so what happened was they looked at the payback, that ROI, and the payback period, literally where you went to zero cost, where you can start making money now, went to less than half, from 6 years down to about 2.7, less than 3 years. That was huge, and that really helped them understand what they wanted to do. Now, you can see some of the things that they did here, and it talks about the slide, and you can read yourself. You learned how to read years ago. But something I wanted to bring up was something else that's not here. Something else that they noticed was that they had, just for safety's sake, they kept on, basically for security at night, not during the day when people are there, but at night for security, they kept on basically 25 to 20% of the light fixtures on to full for security. That's good. That's fine. But what they also learned that they can start saving energy with is, if we use an aux sensor in a different way, we can take these 20 to 25% of these lights that we're using basically for a night light, and we can bring their level down at night. Maybe not, we don't need 100%, maybe 50, maybe 30, maybe 10% in certain areas. We still get the security because that's still plenty of light, but we're able to bring that down in those times that are not between 8 and 5. That was a lot of energy savings, and actually helped to save the New York Times over and above the light power density that they brought down for the LED fixtures. They saved approximately 38% more because they did all these types of schemas in energy. So they saved a good chunk, of energy per square foot, 38%, almost 40% more than the savings they did where they already went down to 0.7 watts per square foot. And think about this. This is something you can do. You can always go back to your client and go, you have these hallways. And these hallways, when they're not being used, you keep them at, we put aux sensors in your offices, and we put aux sensors in your conference room. But you have these hallways, and how about these hallways when they're not being used? We put aux sensors, and we're not going to turn lights out. But when nobody's in the hallway after a period of time, we're going to turn the lights down. Maybe 50%, maybe even more. And by the way, that's where codes are going. ASHRAE 90.1/2010 is having you do that in stairway automatically. Basically, Title 24 is having you do that in corridors and hallways. So codes are going that way anyways. To start to actually take the areas that we were leaving lights on, which is plenty of square foot, and actually saving area. Again, you can go back and you can do some real good stuff with your customers. And wireless makes it easy, fast, and very profitable for everybody. Don't forget, a big deal today is also not only taking that sensor data and putting it into a lighting system, but also sharing it with our friends in the HVAC world. Here's where we have the capability using wireless capability, not only talking to our lighting, but maybe talking also to that air handling unit, that VAV box, and going, hey, we don't have anybody here. So they can bring that down also. So we can start to share our data. The intelligent building is the thing that I hear today all the time. 10 years ago, I remember when I got into, when I was becoming a lead AP, and I'm also a Green Globes professional. I used to get into sustainability big time because that was the big push back then in the early 2000s, mid 2000s. Today, the big push, that's almost a given, sustainability. Today, the big push, of course, is the intelligent building. We want our systems to start to work together, and here's a simple way to make that happen, where you can now come in and say, yeah, I can let that aux sensor actually talk to the HVAC system. Maybe we can actually help them out too. Again, you look like the hero. Again, what we learned to do this up front, to engage the design team. You've heard this many times in all the whether it's LEED, whether it's Green Globes, all the sustainable building rating systems are telling that integrated design approach to get everybody involved, to get understanding of exactly what it takes to put things in, to get a good understanding of, well, what am I saving? How much time am I actually saving? If I don't have to put in I want to see, maybe I want to see videos on what it takes to put this thing, put a wired sensor in compared to a wireless. How much time am I saving? Can I get, can I do more in a day? I need to believe this. I need to understand it. That's absolutely on you. Also remember, the energy codes are starting to push commissioning from a qualified person to actually, well, it's not really commissioning. It's actually factory, basically factory startup, factory verification, or not factory, but verification, system verification is what it is. Not necessarily whether it's a CXA, a true commission agent, but some authority that understands that the system is working properly the way it should be. That's also the new push. Remember that. That's within the new codes. That's one of the new things that happened in ASHRAE 2010 in the different energy codes that have happened in the last few years are pushing for that. The Empire State Building took advantage of it. You can see some of their accolades from LEED for existing buildings in gold. I always look at the word E-bomb. Never say that in an airport. Existing buildings operation and maintenance. All the different capability and all the glowing reviews that they've had. All this translates to money, prestige, profitability. That's the good thing about this. Again, wireless lighting controls gives you solutions with benefits, solutions for you have to to mitigate your risk. Like I said, got to put that control on that pinnacle, on that glass conference room. Really, we need to be able to add a sensor because we didn't know that they were going to put a partition in this room. Oh, great. How do I add the sensor? Nobody had that on the plans. What do I do? How do I move the existing sensor? Mitigate that risk. Add those sensors into that hallway now, where the lights were on at 100% 24/7, except when the time clock went through and turned them down. But maybe they didn't turn off that hallway because we were worried about security. Now we can at least turn those lights down when nobody's there. Don't think about aux sensors just always turn lights on. Think about, or off, how about turning it down? Because again, the codes are taking you there anyways. Why don't we think about it? This is a good example. Cost savings of it's not just about the sensor too. How about those controls? Empire State Building, literally, I want a control here. Okay, let's pull some wire. Let's cut a J-box. Oh my God, maybe it's a historic building and I can't can just not cut into this, historical landmark. And putting a J box on top is going to look ugly. What do I do? These wireless capability gives you that understanding to, again, solve those problems for your customers. So it's for multiple reasons we're looking here. Because you're being told to by the codes, because it helps you mitigate risk, it actually is profitable for you. It's again, just smart. So again, just to keep it, turns the lights off based on occupancy or down based on occupancy. How many square feet in a building can you go to where you can actually turn, that it's not being touched 24 hours a day, lights are on full. It's that hallways, it's those stairwells which are being pushed now, it's those corridors, it's those atriums. How about tackling those areas and bring lights down? You can save some energy. Daylight harvesting, all that glass outside. Sustainability was a great move. They pushed for so much glass outside the building, but now we need to take care. We need to use that light. We have the lights on, but we still have full daylight coming in. Again, that's starting to be pushed by codes. People can manually turn off, down, put lights to what they need it to be, control their lights. Again, trim the high end of those fixtures. Maybe you can bring those lights down. Most rooms are actually overlit, not because somebody specified wrong, because they didn't know that the walls were going to be reflective white, and so was the work surface, the desks, and so were the carpets, because that light source is only part of the light in the room. What is the reflectivity of the room? That's the other major part of that room. And if it's really dark, it'll absorb the light. You got the room with the same same light source, but if the room is dark, a room has dark non-reflective surfaces, that room is going to look half as lit as that room with light reflective surfaces, and you don't know it till the room automatically goes in. Bring those lights down if that's the case. Those type of things all help you. And with that, I'm going to take it back to my friends at Graybar, Alan DeCarl, and let him finish up with this presentation.
Thank you very much, Scott, for the information you provided us today on controls, particularly the example that you provided for the Empire State Building. That was very enlightening. But before we move on to the questions, and we have several that I'd like to go over that I'll restate from the ones that have come in from the attendees that have watched the presentation. I did want to remind everybody that Graybar has a service that we offer called the Graybar Power Smart Rebate Advantage. This is an opportunity for us to help our clients calculate rebates, both prescriptive and custom, based upon their zip code where you are in the country. So we have a whole team of people that can work with you to help you calculate exactly what a rebate might be if you wanted to go into a retrofit or renovation kind of project for lighting that also includes the controls, and we can calculate and get the exact calculation for you for that rebate. If you happen to be on this call and you work with in a campus environment or multiple buildings, maybe around the country, we have a program that can help you do that, the zip code by zip code, calculate those rebates. There's two programs. One, we can give you the number and tell you what it is, and the other one is a service where we can actually help you gather up and we'll help you with the submission of the paperwork, and we'll collect the money on your behalf for you. So I wanted to let everyone know that we had that service. So there are a couple questions that came in, Scott, and I'd like to go over a couple of them. If you have any questions, you're listening in, be sure to type them into the Q&A dialog box. They'll pop up on our side, and we'll go over them as time permits. One question is about every light source in the space being addressable. We know that spaces inside buildings change. Sometimes it might be full office space and a bunch of cubies, and then we take the cubies out and we're going to turn it into an engineering space where we need a different type of light. And it would be nice if we could address every light source inside the building independently and create different lighting zones. Is wireless going to offer that to us, this ability to have this fully addressable type of lighting system in the future in our buildings?
Oh, stay tuned. Absolutely stay tuned. Yeah, I mean, obviously the first step was we all learned the advantages of the individually addressable fixture. The capability for churn, if somebody wants to reconfigure that we don't have to, if somebody decides to make, again, this office 2 offices or make 2 offices 1 office because somebody just got a promotion, we don't need to reconfigure, the zoning within that room. And plus again, mitigating risk, the individual addressed lighting fixtures to be able to zone afterwards where you don't have to look at, the architect, the engineer, the lighting designer, and the electrical contractors in the room going, I thought I wanted these zoned differently, and the other one saying, no, it wasn't on the plans. Look at the construction documents. We've all been in those conversations going, no, it should have been, no, it shouldn't have been, and back and forth. When you're individually digitally addressable, you can say, okay, I want these to play with these and this one to play with this one. And then if you want to change it, you just do it digitally by a PC. Now, taking the next step, we all know where the next step's going to be, and it's going to be wireless, individual wireless control on fixtures. And I know there are many companies, I'm saying absolutely nothing, that are looking at this way because yes, that is the next logical step, no question. And so look out 5 years down the road, 10 years down the road, where this is going to go, it's going to be fun.
So when we talk about the items that we see in the office space or in the building space that the consumer and the building management people actually interface with, I'm thinking of 3. We have the switch on the wall. We have possibly an aux sensor. And then if there's some outside light contribution, we may have an ambient light sensor. In the world of wireless, are you telling me that every one of those devices, the switch on the wall, the aux sensor or vacancy sensor on the ceiling, and the ambient light sensor that we may have, none of those are wired? They are literally lick and stick, put them up on the wall, and they look like a wired device, but they're actually not.
I love the term. I have to remember that, lick and stick, but absolutely right. That's exactly right, that they all can be wireless. Or a portion can be wireless. Or, what is best? The point is, and I'm not saying wireless will take over wired, because it's, but it's what's best for your application, what's best for what you want to do and where you want to do it, and how, and what you feel like it. Because you always remember you balance it out with, and as I said, and this is something for why you talked about wireless fixtures in the last question. You're getting me going now, because you talked about wireless fixtures, but something we also have to remember, what I said at the beginning, it has to work, and it has to work every time. So if you have a lot of fixtures happening, what's the schema? What's the protocol? What's the functionality? How can you make sure that when I push that button on the wall, that what fixtures I want to turn on will turn on every time, and will turn on right away, and not take 30 seconds or 20 seconds, because that's an eternity for lights. But yes, everything can be wireless. It can be, or partially everything can be wireless. It's what's best for your application. Maybe I do have wired, but I want to add some extra stuff because I want to add, I need to cover a little extra area, but I can put a wireless here even though I have wired in this space. A combination's okay too. What's best for your application? And that's where it starts to happen. That's how it mitigates risk.
Thank you. Corey asked a question. Corey would like to know, in the project that you did, the case study from the Empire State Building, what percentage of the building's peak loads were reduced because of lighting control? Do you have that data?
I don't have that data that you're making, but we do actually online. Go to www.lutron.com, and even though, yes, I know I am a CDSM, certified demand side manager. I get that. Understand. You can get me in another thing, which is smart grid and demand response and demand management, which is the new thing that is, again, Corey's so right. That is one of the major drives for smart grid, which I'm on a few standard committees for, and that is one of the next new things happening. That's one of the big pushes for intelligent buildings, is for that peak demand capability, because we all understand demand charges in commercial buildings can be as much as your consumption, that KW can be as much. But we do have a white paper all about the New York Times on our website if you want to go in our case studies, and I believe it is in there. But I don't have that exact capability, but that is great, and I'd love to get back to Corey with that, and I will find out.
We'll give you Corey's information so you can send that white paper to Corey. I'll also go up to lutron.com and find that case study and that white paper, and we'll post it along with a PDF of this presentation so all the attendees can get that data. I have another question that came in here, and this is from Barry. And Barry's asking questions about the world of batteries that we have to worry about when we talk about wireless, and what about the maintenance issues associated with batteries down the road? Could you address the battery life, the type of battery that we'll find in some of the sensors and switches that we use in a wireless system?
Sure. He's absolutely yes. Batteries are in there because if you want to do something more than basics, if you want to do just basics, which I know there's other technology out there, so my friends with that technology, but if you want to do something more advanced, you need more energy than will happen just on I'm going to say some basic kinetic energy. What you're going to need is you don't need a battery, but batteries, like we've done studies, the batteries in our sensors last 10 years. In fact, that's in all of our literature. 10-year battery life. Well, 10 years is actually longer than the expected life expectancy of the aux sensor power packs that are out there. Power packs, their life expectancy is 10 years. So my battery is actually lasting longer, and I will tell you, it's a heck of a lot easier for me to replace a battery in that, after 10 years than it is to replace that power pack.
There's another question that comes in that's very close to the one that Barry just asked about battery life, and this one's from Brian, and he would like to know that when a battery begins to getting close to the end of its life cycle, is there an indicator on the sensor, a blinking light or something that will tell us that it's time to do some battery maintenance?
There's not only many times, I'm going to talk about our sensors, and I think most people go this way, but I'm going to take two ways. There's not only the sensor itself tells you what's going on, but it depends on how sophisticated, if it's more of a standalone, everything's going to be in just the wireless sensor, or if it's going to more of a higher, if that's also communicating to a higher level controller, more of a higher level topology controller maybe, that might be interfacing to the BMS system, or doing that peak load calculations, doing some energy management, some historical energy data collection, things like that. A lot of times, also those wireless sensors can also, digitally talk back and go, oh, by the way, I'm actually starting to lose power, and I'm going to go in the next week or so, or the next few days, and that can actually do things. And depending on how intelligent your system is, it can do things like emailing the facility person, oh, by the way, you need to start thinking about changing batteries, in the Smith conference room. Okay. So again, it depends on not only the device itself usually has some mechanism, but if it's also talking to maybe a higher level controller, maybe you've adjusted to a complete building system, not just controllers for that room. Maybe your setup is scalable to just from a single room, maybe to a complete building system or a complete campus system that has more intelligence. Those controllers many times can not only talk to to say itself, but it could also talk to that system, create reports, send emails, and things on that order. So there is capability there, which I think is a little easier than some of the more hardwired communication.
Brian would also like to know if the batteries that we put in these devices that have the 10-year life, are those batteries, are they proprietary, or are they, can we buy them on the open market?
Your local CVS, and I don't want to pick CVS or Ray Derrick, I got to give, wherever you want to go. Yeah, no, not proprietary. Not proprietary.
So they're lithium button batteries is basically what we...
Sometimes button batteries, sometimes it might be a camera battery, but again, it's make sure, at least for us, I'm going to say, and I don't think they're not proprietary. The good thing is, energy storage and battery life is getting better and better all the time too. So hopefully 10 years will be someday it'll be a lot more than 10 years, because that's energy storage is one of the newest frontiers out there for everything.
Great. Before we go, Scott, I wanted to make one comment about wireless and the fact that Graybar has a whole mobility strategy where we help clients, both our integrator partners and bringing opportunities to end users through those integration partners about wireless. And when we look at wireless at Graybar, we look at it three different ways. One way we look at it is what you were talking about in your presentation about Wi-Fi, the 802.11 aspect. And what's Wi-Fi really have to do with a lighting control system? And we look at it in a way that it provides that connectivity to the building management system in a way that doesn't require a wire. So we can get to the building network, and then we can attach to the building network to get us to some of the management items we need. The other part of wireless we think about is using a bring-your-own device where we need cellular connectivity. If you need to connect to the network so you can control your lighting control system, and you need to do it with a cellular connection because you want to get attached to the internet no matter where you are in the world or no matter where you are in a building, we can do that. And sometimes buildings have difficulty getting cellular connections, and we provide services to help do that. And then lastly, we talked about the 400 megahertz in that range, that Clear Connect thing. That wireless is actually device to device inside the lighting system itself. So we're connected together wirelessly, all the items that are in the lighting system. We attach the lighting system to the network, and we can do that with 802.11 unwired. And then we can also access our lighting control system either way, either Wi-Fi or cellular. So I wanted to let our folks know that are online that we can help them with wireless strategies that are adjacent to the lighting control system wireless that we spoke about today. I'd also like to remind everybody that the presentation that you saw today is archived, and any associated documents like a PDF of the presentation will be up on graybar.com. Just look for the G2 Talk logo, click on the archive, you can go there and download the documents. We will go up to the Lutron website, get the case study for the Empire State Building so we can address the question that we had about the peak demand. I want to thank everybody for joining us today on our G2 Talk webinar. If you're one of those 50 people that get a cup of coffee, enjoy that too. We'll look for you the next time we come around with a technical presentation, and we thank you for joining us on G2 Talk today. Thank you, Scott, for being our presenter. Have a great day, everyone.
Thank you so much. Have a great day.